Now I'll make it 0.1 millisecond. We'll see the output. Yes, now sine wave is coming, but you see that it is clipped off because still the samples are not enough to plot my wave on MATLAB. Even reduce it. Perfect. You get a perfect sine wave. So this is the first place where we make mistake. So we write the code is correct, but what is the mistake is we are not dividing the x-axis by the required number of samples. The code is correct, the waveform is also correct, but logically it is wrong because I don't see a perfect sine wave. So even if you divide it 0.001, the sine wave will become even more smoother. You can visually see how the sine wave becomes smoother and smoother. Okay, so this is the basic sine wave. MATLAB starts with plotting a sine wave and cos. You know what is the difference between sine wave and cos waves? Sine wave starts at 0, but cos wave starts at peak. We'll see whether we are getting the sine cos wave or not. Yes, perfect cos wave we are getting. So I'm just replacing sine by cos. And phi, you see, the amplitude peak amplitude is phi. It is not peak to peak. It is the peak amplitude on the positive side of sine, and minus of that is the peak amplitude on the negative side of sine. So peak to peak is going to be 10, and half of that is going to be my amplitude. So phi indicates the positive peak amplitude of my sine or cos waveform. Having uh, known how to plot a perfect sine wave, now we are slowly going into how to plot a discrete level sine wave. So we don't have much difference. Instead of plot, we'll be giving stem. And for notation wise, if you want, you can replace t by n, but MATLAB doesn't differentiate between variables. For MATLAB, it will not know whether it is a discrete wave or a continuous wave. It will just plot the values. If you give plot, you get a continuous signal. If you give stem, you get a discrete time signal. So now see here how the sine wave will look like. Yes, because we have taken more number of samples. I'll reduce this C here. See the code, see, we are not going to have any presentation today. So we are going to write the code live and we are going to visually see the output immediately in the live script. That is the purpose of live script I'm using. You write the code here, you see the output parallelly. If you use normal MATLAB code, if you write the code and run, you will get output in a separate figure window. So you have to switch between windows and see the output, right? That difficulty is eliminated in the MATLAB live editor. So you can write the code live and you can see the output even more live nearby that. Okay. So see here, the time axis, the division is more. So the sine wave looks crowded. Or see here, even I can zoom it. You zoom it, you see, you can see discrete samples if you zoom it. You can see discrete samples. It is not continuous, it is discrete. So you can see stem, correct? How can I make this visualization simple for me? So it is looking like a shaded sine wave, right? So what one thing I can do, I can reduce the number of samples in the x-axis. I'll make it 0.01. Now see the code. It is fine. It is now looking fine. Can you see discrete amplitudes here? Yes, this is a perfect example of a discrete time sine signal. Okay, discrete time sine signal is periodic only when you have a pi inside it. If you don't have pi, the discrete time signal will not be periodic. I am not going into the basics of signals and systems because that is not the thing for today. So I have first task in our today's live DSP coding. We have learned how to plot signals using continuous time and discrete time. Just one difference, plot and stem. Because I told you already, MATLAB doesn't know the difference between CT and DT. It will just execute the command